Alright, problem 4 from 2013. So we actually have a graph. The figure above shows a graph of f prime. So it's f prime. The derivative of a twice differentiable function f on the closed interval 0 to 8. And it has horizontal lines at x equals 1, x equals 3, and x equals 5. The area of the regions between the graph fx and the x-axis are labeled in the figure. Okay, so we know the areas here, 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 here. Okay, so the function f is defined for all real numbers and satisfy f8 equals 4. That's important information that we might miss. Okay, let's go to part A. Find all values of x on the open integral 0 to 8 for which the function f has a local minima. So be careful, it's function f, which is the integral of the graph we saw right here. So justify your answer. So we know that when f prime is greater than 0, the function f is increasing, and f prime smaller than 0, f is decreasing. So we're asking to find a local minima. The minima is decreasing than increasing. So we should find a place where the graph of f prime goes from positive to negative. So the only point we see in the graph is right here. It's x at 6. So that's part A. Based on the scoring guideline, we just got 1 point for part A. Let's go to part B. Determine the absolute minimum value of f on the closed integral. So on the second question, it asks for the absolute value. There are 3 possible places where the absolute minimum will be located. So the first one is we did in the part 1. The local minima might also be an absolute minima, which is at x equals 6, and then is the both endpoints might be a local minimum, which is x at 0 and x at 8. So we have to use the fundamental theory of calculus to figure out which one is the absolute minimum. So f0 should equal f8 plus, in this way it's reversed integral because we're looking for f0 and f prime fx dx, which we know f8 equals 4, and based on the graph, I said it's reversed, so it should be 8 to 0. It's 4 minus 7 plus 3 minus 6 minus 2, which equal negative 8. Then for f6, in the same way we use the fundamental theory of calculus, f8 plus the integral of 8 to 6 f prime x dx, and we got 4 minus 7, negative 3. So we figure out that and we also know f8 just 4. So compare these 3 numbers. Negative 8 is the absolute value, which we answer the question at x equals 0, the graph of f has the absolute minimum, and it equals -8. Now let's see part C. What open integrals containing 0 to 8 is a graph of f both concave down and increasing. So as I said before, fx greater than 0, the graph of f is increasing. And when the second derivative of f is smaller than 0, f is concave down. It is also true that when the second derivative of f is smaller than 0, f prime is decreasing. So let's see the graph. When f prime is greater than 0, so that part is cancelled. We can and when f prime is decreasing, so right here is decreasing and greater than 0, and from 3 to 4 is also decreasing then and greater than 0. So our answer is between integral 0 to 1 and 3 to 4. The graph of f is both concave down and increasing. So let's go to part 4. And we also get 2 points for correct answering part C. The function g is defined by gx equals fx to the cube if f3 equals -2.5. Find the slope of line tangent to the graph fx. So we have to find the slope of the line tangent, which means we have to find the derivative at the point 3. So let's first differentiate gx. So that's a we should use the chain rule for derivative because fx is actually a function. So first we differentiate the outer part, which is 3fx to the squared, and then the inside part, which is fx prime, and then we plug in x equals 3 to the equation. 3f3 squared times f prime x. We know that f prime, we were told that f3 equals -2.5, so -2.5 squared, and based on the graph, we know f prime of 3 equals 4, and the final answer is 75. We got 2 points for correctly differentiate gx, and 1 point for the answer. Okay, and that's it.